Okay, hi everybody. Sorry for my late movie. That's all right. You'll survive. I made a mistake already. I was going to do a real quick review of what we did Friday for those that perhaps were absent. Um, blah blah blah. So we started off with section 5.1 as if we had a book about solving proportions. And I'm not going to do really much in this because the ability to solve through proportions happens quite a bit in the next couple sections anyway. So hopefully your math is good, but you can solve all of these four by cross multiplying. Check your notes from your friends, especially when you're absent. Hopefully you have a connection there to see someone what we missed. When you cross multiply this one, x plus 5 times x minus 3 has to be FOILed. So, a little bit higher end kind of question there as far as what we have to deal with. Blah, blah, blah. So you'll see a lot of that. Section 5.1 had nothing to do with geometry. It was just practice on that situation. Because what Chapter 5 is all about is similar polygons. Similar polygons are not equal, but what they do have, similar polygons have equal angle measures. But the side measures are proportional, not equal. See, if the side measures were also equal, then these would be equal congruent figures. You can see this one's much smaller than that one. So these angles are marked as equal, equal, equal. Sides certainly are not, but what they are proportional. Look at 10 over 5, 14 over 7, 12 over 6. Those all equal 2. So you can say these are similar. Your job is to actually line up the letters just like with equal or congruent figures. And so letter A, which is the one marked angle, must correspond with letter X, and so on and so on and so forth. So this is the symbol for similarity. Not only triangles could be similar, any kind of polygon could be similar. This is not, because you don't have a similarity ratio. Here is two parallelograms, perhaps, or let's just say quadrilaterals that are similar because they're stated as similar. And then again, in the name, it's all about the letters being in the correct order. So here you can see some of your answers. Use that if you were absent in order to figure out what you missed. All right. So then they say they are similar. We'll just have to assume as they look, that's how they're similar. So then this is where the proportions come in. 4 goes with 10, so 1.5 goes with x. So 4 over 10 equals 1.5 over x. Cross multiply, solve, blah, blah, blah. All right, so real basic there. All right, so giving you a real quick lowdown because actually I'm just doing this as a favor for those that were absent. Okay, so angle postulates. Oh, sorry, just kind of jumping around. So now we get into, if there was a book, section 5.3, which is specifically just triangle similarity and some things that some postulates that, just like when we had congruent triangles, these postulates, for instance, let's start off with AA. What AA says is if I have two triangles where one angle is equal to another angle and another angle is equal to another angle, so two sets of angles are congruent, that is all you need to know that those two triangles are similar. Basically, AA really could be called AAA because we know three angles in a triangle add up to 180. So if these were congruent, let's just put some angle measures, and then let's just say this was 50, so this would have to be 50 because they're vertical. Well, then these add up to 80, so therefore in both these triangles 100 degrees have to be left over for that last angle. So if I tell you that this angle is equal to this one and this one is equal to this one, there is no way, that could not be equal to that one. It's impossible. So the way this was marked to begin with, though, was just this. So you as a student would have to add that this angle is equal to that angle because vertical angles are congruent. Then, blah, 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 you could say this triangle is similar to this one, not necessarily congruent, by the AA postulate. And again, order of the letters is important. A must go with R. Blah, blah, blah. You should be able to get that and figure that out. So another similarity theorem is side angle side. But this is a little tricky, and you need to figure out how this works out. So first of all, these two angles are congruent. by vertical angles theorem. And then the next thing is, all right, this is not congruent triangles. So what you have to do is find out which side goes with which so I could see a similarity ratio going on. First time I've said that word. So 2 over 4, that equals a half. 4 over 8 equals a half. So that is the correct combination of numbers that give me a similarity ratio, 1/2. So these two triangles are similar by SAS. Then what you could do, and you'll see later, I'll just wait till it goes later, because again, I'm just kind of real fast tracking this. And then side-side-side similarity, that is if I have two triangles where 3 sets of sides are equal, then the triangles must be similar. Not equal, I'm sorry, proportional, all right? Because we're dealing with non-congruent triangles. So I apologize for saying that. All right, and then looking at these, just a couple of examples. Why is letter A, these sets of triangles, similar? It's not because of the 12 and the 8. It's because 30 is equal to 30 and 90 is equal to 90. So, okay, so it's by angle, these are similar. Then what you could use is these two sides to write a similarity ratio. So that's the only thing you can do with those two sides. So this has nothing to do with side or side angle side, because there's not enough sides to compare. So like I said in class, the similarity ratio depends on your perspective. From large to small, this is 2/3 as big, but when I go the other way, this is 3/2 times larger than this one. So similarity ratio could either be 2/3 or 3/2 depending on which way you go. Close to side. How do I know who goes with who? 4 is the smallest side in this triangle. 8 is the smallest side. So 8 should go with 4. 8 over 4 is 2. 10 over 5 is 2. So I'm excited. But then 13 over 6 is not equal to 2. So these two triangles are definitely not similar. Okay, blah, blah, blah. AA. Right? And then, how do you go about doing these? Explain why these triangles are similar. A is why they are similar. Then I may proceed and compare the sides. Now, how do I know who goes with who? Well, 5 is opposite this one marked side, so X must go with 5. So make a choice. I'm going to go left over right, so 5 over X equals 6 is opposite the non-marked, and so is 9. So 6 does go with 9, 6 over 9. And then cross multiply. All right. Why are these triangles similar? Well, this angle is equal to this angle. So there's an angle. And then what I must prove is, well, do I have a ratio I could set up that's true between these? So the correct one is not 8 over 15 equals 12 over 10. 8 over 10 equals 12 over 15. And those are both 4/5. So it's side angle side that these are similar. Then you may proceed and find X by using one of these two ratios that represent the correct combination of sides, and then take 8 over 10, for instance. Right over left is the way I'm going, so it must be 11 over X, right over left. Make sure you keep the triangle order intact. All right, and then get some sort of decimal for that. I didn't finish that off in class. All right, and then why? This one's a little trickier. I did this one on the board for everybody. What's similar is this. Possibly is similar to this triangle. That might be what's going on there. So, notice what we have here. This angle is equal to itself. Both triangles share that angle. So 12 over this green side is 20. And that's what should correspond to that side. And just like this in the yellow triangle, 15 should correspond with 25. So 12 over 20 equals 15 over 25. Yes, you get the same similarity ratio is what we can use the term for now. So you could say these are side angle side is why they are similar. And then proceed on and maybe take the similarity ratio, 3/5, small to big, and compare that to 17 over X. All right? Or you could go 12 over 20 equals 17 over X, the two sides that correspond to each other. Long story short, cross multiply and solve, blah, 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 did that one. And then we did that one in class, and I'm done with this. Okay, let's see if there was anything else I wanted to look at. I think that was that. Then we just did a few more examples that you can take a look at real quick. I believe we looked at quite a few of these in class. So I did 11 real quick, then we talked about this tree example of bouncing off there, but this is another one. But it's a little different though. With these two being parallel, then I could say these two angles are equal because they're corresponding. So that's a corresponding angle postulate or theorem. Two sides are parallel cut by a transversal, then corresponding angles are congruent. So these are similar by AA. So I may proceed. 3 does go with 8. 3 to 8 equals 4 over 4 plus x. Right? And then this is where you'd have that distribution and solve. So just take a look at that and then read this word problem, how a tree and a person create similar triangles. That's it for your review for not being in school.